My name is Brandon Hillier, and I had the fortunate opportunity earlier today to meet Dr. Stewart Cohen, Adjunct Professor of the Department of Forest Resource Management at the University of British Columbia. A senior researcher, Dr. Cohen focuses on regional assessments of climate change impacts and adaptation. In particular, he and his colleagues have recently been investigating the potential changes in snowpack on the North Shore Mountains overlooking Vancouver. This snowpack, which feeds our Metro Vancouver area reservoirs, could raise potentially troubling issues in the nearby future. Dr. Cohen attempts to address these issues, bridging the gap between climate change research and adaptation planning.
Hello, my name is Stewart Cohen, and I'm a researcher with Environment Canada, and I also work at the University of British Columbia. One of the things I do at the University of British Columbia is I teach a course on climate change called Climate Change in the 21st Century. I wrote a textbook with that title. It was published by McGill Queen's University Press. And the theme of the book is to discuss how to make connections between what climate scientists do to project future climate and what the concerns might be at a local level. How might a future climate affect watersheds, forests, food production, coastal zones, fisheries, and people? This concern is given the name climate impact assessment. So if there's going to be a warmer climate, what might the impacts be? And if we can understand what the impacts might be, how might we plan for this? How might we adapt to this? And one case that I'd like to illustrate for you is a case involving potential changes in snowpack on mountains that supply water to the city of Vancouver. So what we have here on the screen is the beginning of this story. We have a scenario, a potential projection of the future, in which in the Vancouver region, less of the precipitation that we would normally get in the mountains of Vancouver would fall as snow and more would fall as rain. The potential, therefore, is that the snowpack that we have in the spring might be reduced. And if we have a shorter snow season and an earlier snow melt, what might that look like? Well, here at the university, there is a group that actually does visualizations. And so I brought this visualization group together with some colleagues of mine from Environment Canada that had a snowmelt model and generated future snowpack. And what they produced was this graph showing how the elevation for snow on a typical April the 1st might change in a future climate change. This label here refers to a projection of future climate. The A2 refers to a very high emissions scenario. And this elevation here is elevation above sea level. So what you're seeing here is where, according to this snowmelt model, the snow line on April 1st of each year is going to be. And you can tell from this graph that it looks like the snow line is going to reach slightly higher elevations over the period of this model simulation. But suppose we could actually put this onto a three-dimensional graphic. And so the group here at the Visualization Lab here at UBC, led by Professor Stephen Shepard, was able to produce this three-dimensional image of Mount Seymour, which is in the district of North Vancouver, and they put on this white coloring, which shows where the snow line is on April the 1st. And right now, you're seeing an image of where the snow line is in the year 2000. If we advance this forward, you see that it moved up just a little bit, consistent with the change in the output of the snowmelt model. If we advance a little farther, now we're over here. See, it's slightly higher up now, and it shows that on the image. And finally, we'll go out to the end of this simulation, where the snow line is now at a much higher elevation, and so here it is. That's what it looks like from a side view. Professor Shepard's group also showed this from a top-down view. So this is the first picture of the current day, 2020s, 2050s, and 2100. So if we get a warmer climate, this is how the snowpack would visually change on this landscape. And what we hope to do with pictures like this is to help to make the connection between climate science projections, a physical impact that might occur on our landscape, and what that might mean for the management of that landscape. So in this case, we were speaking with the engineers and the water managers for Metro Vancouver and asked them, well, what's the best way to adapt to something like this? Because if we have less snow, that affects how reservoirs are managed. That affects how water is managed during the growing season. And so if we can make these connections between climate science, climate impacts, and adaptation, then hopefully science will be able to enable adaptation planning to occur, not just among engineers in Metro Vancouver, but anyone who's interested in water issues and similar issues around the world. So this has been my role in the climate change issue, is to enable this kind of integration between climate science, impacts, and adaptation planning.